Hi, I'm Darren and welcome to Level Up Double E Lab. I have finished the restoration project on my Heathkit DX-60 and it turned out great. Let's check it out. Before I apply AC power to the rig, there are a couple of sanity checks that I want to make, starting with the primary side of the power supply. So to do that, I've got the function switch set to off. And what I expect to find here is open circuit between the hot and the neutral. So let's check that. And I got my multimeter set on ohms, and that's reading that it's open circuit, so that's good. I also expect to see open circuit between the hot and the ground and the neutral and the ground. And these did jump up slightly. At least one of them did when I put the leads on there, and that's okay because it's just charging those safety caps briefly. So that checked out fine. Now what I want to do is make sure the power switch is working correctly. So I'll put the leads back on to the hot and the neutral, and I'll switch the rig on. And when I do that, I expect to see somewhere between maybe 100 to 120 ohms, because remember, I've got this inrush current limiter on the primary side of the power supply. So let's check that out. So that's 112 ohms. So that's good. That's believable. That certainly passes a sanity check. Next up, I want to check the secondary side of the power supply. And to do that, I'm still going to check resistance. In this case, I'm going to connect one end of the multimeter to the chassis, and the other end is going to be a probe. And what I'll do, I'll just probe the plus 600 volt side of the power supply. And what I'm looking for here is something that's just high resistance. I'm not looking for an exact value. In fact, it's bouncing around quite a bit, which is fine because I'm looking for to make sure there isn't any short there. It says 24K. It's going to bounce around as the caps charge. So that's fine. That certainly passes a sanity check. And I'll do the same thing over here for the bias board, the minus 130 volt board. I can probe this point right here. Let's see what we got. 50K, 47K. It's dropping, which is fine. Again, I'm looking to make sure there's no short there. And clearly that board and that side of the power supply is working fine too. Next up is a quick sanity check that I can do in the meter to make sure that it's measuring the current in the plate current mode and the grid current modes correctly. It's very easy to do. All I need to do, and I'll put up the schematic on screen here, is just connect a little bit of voltage up across that circuit and put my referee ammeter, in this case my multimeter right here, in series with those connections, and I'll be able to compare the two and make sure they're reading correctly. Now I did also, for the plate current mode, introduce a little bit of additional resistance, just 10 ohms in this case, just to give me a little more range on the power supply as I apply the voltage. So let's turn on the voltage and see what happens. We can see both of them are tracking. That's good. Now that's about 125 milliamps. Let me bring that up to about 250, which should be full scale. And that's pretty close. It's not right on the one indicator, the 1 milliamp indicator, but it's certainly close enough for me to be able to tune the rig. Quick change in setup, and I'm ready to measure the grid current. Of course, I have to put the selector switch on grid. I did change my inline resistor to 470 ohms just to give me a little more resistance because this circuit is different. And of course, I also have to change the connection on the 6146 tube socket from pin 6 to pin 5. And then the way the circuit works, I have to change the other connection for the power from, I think it was on the chassis for the plate current mode. I moved that to the 100 or negative 130 volt bus just before the meter itself. But the same principle, I'm going to adjust this 2718 in the background until I get to 5 milliamps in this case on my ammeter. So here we go. About half scale. And that's close enough, about 5 milliamps. But notice the analog meter is reading about 0.8 milliamps. And that's the phenomenon that I noticed a few episodes ago when I was studying how Heathkit designed the meter circuit. For whatever reason, it seems to read a little bit low. But at least the way that I've constructed this is mimicking the original Heathkit meter function, so I should be okay. Next up is to make sure the power supply is working fine, and I've got a bit more of an elaborate setup here to make this measurement. I still haven't put the tubes in the rig. I don't need the tubes to do this test. But what I do need, of course, is my dim bulb tester, so I can bring up the AC voltage slowly, and of course use the light bulb here to keep an eye on the current draw, make sure there isn't anything drawing way too much current. On the secondary side, I've got 3 meters set up. Top right corner, right here. Got my Heathkit, that's measuring the voltage on the high voltage, the 600 volt DC circuit. The multimeter here, this guy, is measuring the bias circuit, the negative 130 volt circuit. And then the little guy at the bottom, that's connected to the AC filament. That should be about 6.3 volts AC. Now, a couple other precautions. I am wearing safety glasses. I'm a little nervous in case, I do have a bad connection in there and we get some sparks or whatever. It's not a bad idea at all to put safety glasses on for this test. And of course, I've mentioned this before on my channel, I like doing these first power-ups with this setup with all the meters connected so I don't have to touch the rig. The only thing that I'm touching is the knob on the dim bulb tester, so it's a lot safer than trying to probe around an open chassis while you're trying to verify if something's working correct or not. So I'm ready to go, so let me flip the switch and see what happens.
This item contains hazardous voltage and safety precautions must be followed. If you're following along and working on your own version, you're doing so at your own risk.
Start bringing up the AC. And I'm seeing a response on all 3 meters. That's good. The bulb is not glowing. That's even better. Around 50 volts. Let's keep going. $90 volts, 104, 105, and the bulb is starting to glow very faintly, and that's about as far as I can go with that bulb in circuit. I'm looking at the meters here and everything seems to be fine. The 600 volts is a little low, but notice that it's creeping up. I think what's happening is as that inrush current limiter is heating up, it's dropping its resistance even more. So I think what will happen now is if I take the bulb out of the circuit, let me do that now. So the bulb is out of the circuit, and I'll bring this up to about 115 for line voltage. There we go. So I'm at 610, it's still increasing slightly on the high voltage circuit. Negative 130, that's good for the bias, and 6.1 volts for the AC filament supply. So all 3 of those look really good. So this power supply passes the test. I'm going to perform the initial tests and adjustments, and those start on page 33 of the assembly manual. And what I'm looking for here is to see if the rig will make RF power, and if so, can we tune it on all 5 bands and still have the grid currents and the plate currents match expectations. So as far as the rig itself is concerned, I've put the tubes in and put in the tube shields. I've installed all the knobs, and I've actually got a separate mini episode forthcoming on these 5. These were all cracked, and I had to come up with a way to repair them, and I repaired them, and I actually think they're working better than they were originally. They're very solid and secure now. And as far as the rest of the setup goes, I'm going to pan back out here for a moment so we can see the full setup. Of course, I need a dummy load to put the RF power into, and I've drafted my Drake MN4 just to use the watt meter. I don't need the antenna tuner portion of it, but it's got a decent watt meter built into it, so that's in series between the rig and the dummy load. And of course, I'm still using the dim bulb tester. I bypassed the bulb and set it to near line voltage just so I have another safety device in between the rig and line power for now. And then lastly, I've got this old Turner microphone that I'm going to use just for the push to talk function. Okay, so for the first test, it's basically just a power on test, looking to make sure that the tube filaments light up, that the other indicators, other indicator lamps light up, and of course that there's no magic smoke coming out anywhere. And before I turn the power on, I have to put an 80 meter crystal in socket X1, and I've done that. I got a 3.707 megahertz crystal that I put in that socket. All the controls need to be in the max counterclockwise position, except the final tuning that needs to be set for the 80 meter band, and set the grid and plate switch to the grid position, which I've done. And what I'll do here, I'll turn the switch to standby, which will turn the power on inside the rig, but there should be no RF power coming out of it if I wired it correctly. And I'll just let it warm up for a few minutes. So here we go. You can see the red indicator lights coming on, so that's good. And the back illumination lamps for the meter are on. I'm looking at the dim bulb tester voltage. It seems to be fine. I know you guys can't see it, but if I stick my head around to the side, I can see the tube filaments look like they're glowing. So I am going to let this set for a few minutes, let the tubes warm up, and then move on to step number 2. The second step, I want to verify that I can set the grid current to 2.5 milliamps. And if you recall, when I replaced that Heathkit meter, I don't have the same scale anymore. So 2.5 milliamps on the original Heathkit meter is 0.5 milliamp on this meter, which is about half scale. So that's what I'm going to be looking for. The specific procedure here is I'm going to set the drive level to about 1. I'm going to turn the switch to tune and then key the mic. I'm going to adjust the drive tune, this control up here, to get to maximum output on the meter, and then readjust the drive level to get it to 2.5. Again, half a full scale on the meter. And then when I'm done, return the switch to standby. So here we go. Turn this drive level to about 1. Key it. I've got current. I want to peak that. Right there. I'll turn it off for a second. Then I'll key it again and then dial this down until I get it to about 2.5. And then double check to make sure I got it peaked, and I do. So that's good. Back to standby. So that's responding exactly how it should. In the third step here in this particular setup, I'm going to be making some RF power. So we'll be watching the power meter here and seeing just how many watts this old rig can put out. The procedure is a bit complex. I'll walk through it here verbally and then I'll just do it. But essentially what I'm going to do, move the switch from grid to plate. The function switch goes to AM. I'm going to key the mic and adjust the final tuning for the dip in the plate current. Then I'm going to switch over to CW mode, start advancing load with the load control, and then continuing to look for the dip in the plate current and keep going back and forth doing that until I get to 150 milliamps plate current, which will be 0.6 milliamps on my meter. Switch it back to grid mode and then readjust the drive level for 2.5 milliamps. Again, that'll be 0.5 on my meter. Return it to plate and then switch to standby, and then it's tuned. And at the end of that, we'll see just how much power I'm able to generate. So here we go. I'll look for that dip right there. Okay, got some RF power. I'm going to switch to CW mode, and I'll turn up some load, about 1/4 of a turn. Again, look for that dip. We're still there, and we're getting pretty close to 0.6. There we are. Dipped. And we're at just over 50 watts output power. And I'll switch this back to tune, check the grid current, and we're still right where we should be. So this rig is tuned. It's making decent RF power on 80 meters. Okay, for the fourth step now, I'm going to set the audio gain control for the AM mode. And I've changed the setup. I put the bottom cover on the chassis and set it right side up. I've also inserted my 40 dB power tap in between the rig and the dummy load and the power meter so we can take a look at the quality of the transmitted signal on the oscilloscope. I've also switched microphones. I switched over to my Drake model 727. It's not the best microphone in the world, but it has two things. It's got a push to talk button, and more importantly, it's got a ceramic microphone element in it. We need a high impedance input for this DX-60. And for this test and the remaining tests, I've got a cooling fan running in the background. That's to put some forced air over my 15K resistor block. Now, I made a small mistake there in the part size selection. Each resistor dissipates 6 watts, which is below the 10 watt rating. However, I neglected to look at the temperature rise graph on the datasheet. Now, even though I'm running these at only 60% of their rated wattage, that still means in still air, the surface temperature would be 150 degrees C above ambient, or 175C in a 25C room temperature ambient. So 175C is almost 350 Fahrenheit. Now that's really hot. And considering the eutectic point of lead tin solder, which I built this rig from, is 183C, I'm flirting with disaster here. The solder could soften enough that these resistors literally could fall off the board, let alone the hazard of just how hot they are. So I'm going to modify this design to double up on the number of resistors. I can get these Yago 10 watt jobbers in 33 kiloohms, so putting two of those in parallel gives 16.5K to replace 15K, and that's close enough. And now the power dissipation per resistor drops to 2.7 watts, or 27% of its rating. Looking again at the temperature rise graph, that drops the rise down to 90 degrees C above ambient. That's still hot, but quite a bit cooler, and it gets me out of the solder melting danger zone. So I'll be doing that as a future mod to this rig. Okay, so back to the procedure. What I need to do here apparently is adjust R28, that's the potentiometer on the top of the chassis, until my speaking voice causes the meter while I'm transmitting on AM mode to peak at about the same level of where I've tuned it for CW mode. And if you recall, for CW mode, I tuned the plate current to be 150 milliamperes or 0.6 milliamperes on my replacement meter. And so the rig is still tuned right now. So I'll go to CW mode and I'll key the mic, and we can see the current come up, and we can also see a nice waveform and about 60 watts of power on CW mode. So when I put it on AM and start speaking into the mic, we want to see that peak come up to near there. So I got the mic set pretty well right now. It's peaking close to that level. To really get it set in, I need a different apparatus. And what I do have a Heathkit SB610 monitor scope, and that would let me really look at the quality of the AM envelope. And once I get the rig set up in my shack, it's another piece of equipment to try to drag down here to the lab. I'll be sure to look at it on that scope and judge the quality of the AM transmission, and then make further adjustments to R28 if I have to. But at least for now, what I did in another video here, I'll put the clip on right now, is record me speaking and then receiving on another receiver here in the shack. Now, I'm still transmitting into a dummy load, but there's enough stray RF within a few feet of the dummy load that any receiver can pick it up. So here's what that sounded like.
So here's my voice coming through on AM, and I'm trying not to get too much feedback here in the lab, but at least give a quick sample of what the AM received signal sounds like.
I thought it would be interesting to look at the transmitted signal and power on all 5 of the amateur bands. So let's start with where I am tuned right now. This is a 80 meter band, and I'll key the transmitter, and we can see the close-up here of the scope and take a look at the signal. And I've got it tuned for 60 watts, 3.707 megahertz. Okay, and I've got a second crystal installed in socket X2, and this one I should be able to do 4 bands on, starting with 40 meters, and this frequency is 7.15 megahertz. I've retuned for that crystal, and let's take a look at the signal. And that's also about 55-60 watts output. 20 meter band is up next. This crystal will work at 14.3 megahertz. And another clean signal, and about 50 watts output. 15 meters is next, and this crystal is marked for 21.448 megahertz, and pretty much spot on, 21.448 and about 55 watts. Looking good still. And then 10 meters. So this is about 28.16 megahertz and just under 40 watts output power. Now, this was a little tricky to get 10 meters to work on this DX-60. I skipped over doing the neutralization step, and there's also another adjustment to make on the drive circuit. There's a small adjustable inductor that you have to tune to get maximum grid drive at 10 meters. So I did both of those steps off camera. The neutralization is a little dicey on this rig because it's just a big rigid wire next to the 6146 tube that you bend to put a tiny bit of additional capacitance in there to neutralize it out. But I think I got it dialed in close enough. It seems to be stable, and it's putting out decent power on 10 meters. I've got an impressive pile of parts left after this restoration. Now, most of this is junk, and I'll throw it out, like these old capacitors and of course the wiring harness. Go see video number 5 if you missed me building the new one. I will hold on to the hardware and the valuable pieces like the tuning capacitor and the low-pass filter though, and I'll even keep the meter in the hope that I can fix it someday. Now for the final assembly. Here's the bottom plate. This is the side that I painted with the zinc-rich paint. The final amp top shield comes next. And finally comes the cabinet cover. It's got a lot of dents and scratches and a bit of rust, but the paint color is still holding up, so I'm not going to repaint it. And this project is now done. How about a quick video montage? I'm not completely finished with this rig. After all, I didn't put it on the air yet, and I'd really like to show its on-air performance, but unfortunately right now, I have no outside antennas. I had some work done on my house a few weeks ago on the siding, and I had no choice. I had to take my antennas down, and I still haven't gotten them back up yet, but I will sometime this fall, and I'll be sure to put this rig on the air and try it out. I'd also like to be able to check out its performance using a VFO, like an HF10 or a VF1, neither of which I have right now, but I'll be scouring Hamfest this fall to see if I can pick up one, or maybe I'll make a homebrew one. Of course, I do have that 15K resistor block issue to fix, and looking online, there are quite a few mods for the audio front end on this rig that hams have done over the years to improve its sound on AM transmission. So I want to study those and see if there are some improvements that I'd like to make. So all in all, I hope you guys have enjoyed this series on this DX-60 restoration, and I do hope you're enjoying the content on my channel. So until next time, bye for now.